Okay, hello everyone. Today we're going to start solving radical equations. And this is the last part of the radical stuff that we're going to do. We're going to solve equations. Today's essential question, of course, how do we solve radical equations? Okay, that's what we're going to do. And you kind of see how we solve one right here. Guys, again, examples of radical equations. They just have one variable here. So the ones we're going to work with just have one variable. It's not like equals y. It'll just have an x in there. All right, we want to solve for x. We want to find what value of x makes this equation true. Either equation, okay? There's a certain steps for solving radical equations. First, you want to isolate the radical term by itself. Then you square both sides of the equation to get rid of the radical sign. Then you can solve the equation by isolating the value of x and find what x equals. And sometimes it equals two things because you get a quadratic. You get a couple different answers. So you plug them back into the original equation because sometimes you get what's called extraneous solutions. And we'll talk about them a little bit today. We'll look closer at them on Monday. All right, as an example, here's a radical equation. All right, first we want to isolate the radical term. There's 4x underneath the radical, get it by itself. So I add 2 to both sides, so now this side is 8. Once you do that, then square both sides. That gets rid of the radical sign. Just take the 4x that's in the radical and take it outside. And square the other side. So 8 times 8 is 64. Now this left side says 4x. So we got to get rid of the 4, divide both sides by 4. We end up with 16. Okay? And here's another example. There's a 3x inside this radical sign. So first we want to isolate the radical. We'll take the 2 to the other side, subtracting 2 from both sides. So this side now becomes 5. And once you get the radical isolated like this, square both sides. Once you square both sides, then you take what's inside the radical outside, and then just square this side. All right? This says 3x. Divide both sides by 3, and you have your answer. Guys, this is a little more complicated solution here. All right, there's a radical here, so we need to square both sides. When you square this side, it becomes a quadratic. Okay, you have to use the FOIL method to square that. All right, now you got an x squared on this side. But you already have an x squared on this other side, so you can eliminate both the x squared. Combine like terms. Combine the x's together, all on one side. All right, isolate the x by itself, you end up with 4. Okay, sometimes when you're solving a radical equation, a solution does appear, but it's not a real solution. It does not work on the original equation. These are called extraneous solutions. Look at the start of that word, extra. It's like an extra solution. It appeared when we did the algebra, but it's not a solution to the original equation. It doesn't work. All right, as an example, here's a radical equation right here. A radical equation that we're going to solve. We have to get the x minus 1 by itself first. And here we square both sides. When we do that, again, we have to use the FOIL method. So x minus 7 squared is right here. Then take the 1 to the other side and the x to the other side. So this side is 0. All right, so this is the quadratic we end up with here, and we can factor that. So we know our two solutions are 10 and 5. 10 and 5 are the two solutions that we get algebraically. So we're going to take those two solutions and plug them back into this original equation right here. All right, the left side here, we take x equals 5 and plug it back in. On the right side here, we take x equals 10 and plug it back into the original equation. Well, what happens? 10 works. When we get to the end here, 7 equals 7, that's good. That's true. This equation is true. 10 does work. But over here, 5 didn't work. Because we got to the end here, it said 6 equals 2. Well, that's not true. So only one of these, only the 10 works in the original equation. The 5 is an extraneous solution. And again, we'll look more at that next week. Again, another example, this is just checking. If we found a solution to be 3, and over here a solution to be 7, we plug them into the original equation, which is this the equation. Again, I didn't go through this the way we solved it here, but just to show you, this is how you check it. Or when you check x equals 3 and plug it in, you get to the end here, it says 5 equals 3. That's not true. 3 does not work, but 7 does work. When you get to the end here, it says 7 equals 7. That's true. 7 is a real solution. Again, a radical equation, it looks like this. Sometimes when you use algebra, 2 solutions appear. However, only one will work. Again, an extraneous solution is a solution to the equation found algebraically, but it is not a solution to the original equation. All right, just a quick summary here, guys. Remember, you isolate the radical term first when you're solving, and then square both sides of the equation. All right, then you can solve it from there. Once you get your solutions, check to make sure that both solutions work if there's 2 of them. I mean, even if there's 1 of them, why don't you just double check to make sure, okay? All right, guys, that's it. We're going to complete the video checking class. All right, you need to know the essential question of the day. And why do we square both sides of the equation, one of our steps? And you're going to need to define extraneous solution. All right, that's it. Thanks, guys.